Yeah. So we've been talking about different Python programming and artificial intelligence, how Python has been used for artificial intelligence, data processing, and the rest. And one important aspect of artificial intelligence that is very, very important is what is called machine learning. Machine learning. And as the name implies, is like the machine literally learning something. You understand? There's a way you train the machine. That's in this case, the machine we're talking about is like a computer or any smart gadget. You train it that okay, this is the pattern of something, so that in the future, when the machine sees something of that nature, it'll be able to say, okay, this is exactly how it is. Let me give you one example. No, everybody, all of us look at weather report, right? Weather report every day. You see the American meteorological department saying it's going to be that it will be sunny today, tomorrow it will be rainy, next tomorrow there will be snowstorm, tomorrow there will be rainstorm. All those things you are seeing, they did not just arrive at them. They already got data, like maybe the temperature at that particular day or hour, the humidity, different atmospheric parameters. So after they've studied this for some years, they observe that, for example, when the temperature is 80, the humidity is 20, and other parameters are at particular point, is going to rain. So anytime they have a data that shows something of that in the future, their machine will tell them this is going to rain at this particular hour. You understand what I'm saying? So they already trained the machine. So you train your machine. For example, if you have a face, maybe you have, let me use one typical simple example. If you show a face to a machine and say, okay, look at this face that you are seeing. Look at, okay, for example, if you want to show to a machine that, okay, this is a boy, the machine will look at, okay, is a boy, is on low cut, no earring, no, look at some attributes. You understand? Then you also have a girl. You say, okay, this is a girl. There is, maybe there is weave-on or there is a kind of makeup. There is earring. So next time when you show a neutral picture to the machine, what the machine will look for is this picture you are showing to me, is it putting on makeup? If yes, okay, is it putting on any wig? Yes. Is it putting on earring? Yes. Based on the knowledge that the machine already had, it will tell you this is good, this is likely to be a girl. You understand? Or if you look at, if it looks at it and say there is no makeup, there is no earring, there is no wig, then it will tell you this is likely to be a boy. So there is a way you train, and that is what is called machine learning. Machine learning is an advanced technique that teaches computer to do what comes naturally to human and animal. If you look at, just imagine a little boy. Let's imagine a little boy that is, maybe like 2 years old. Gradually, he will recognize his dad. Gradually, he will recognize his mom. Gradually, he will know it is sleeping time, because right from little age, he has been observing those things. He has been observing those things. He has been observing those things. And at a particular point, his memory has been trained that when it is also time, when the weather is dark, when mommy and daddy are at home, everybody is not putting on like suit, everything, it is time to sleep. So the brain has already adapted to it. So that is why this definition say it's an advanced learning technique that teaches the computer what to do. That is computer to do what comes naturally to human and animal. For example, you and I, can you actually remember a time when you know it is time to eat? No. Could you actually remember a time when you think it is time for me to go and cut my hair? No. Because with time we're able to develop the process that, okay, when my tummy is doing me this way, when it is at this time of the day, I should know I should go and take my breakfast, or I should go and take my dinner, or I should go and take my lunch. So in this situation, in this kind of situation, if you want to tell your laptop, to your machine, to computer, to tell you when to eat, you can say, okay, when it is 8 o'clock in the morning, when my tummy when it is maybe 2 hours after I woke up and you see me brushing my teeth, give me an alarm that it is time to eat breakfast. So naturally, you train your body. In the same way, you can train the computer that, okay, when you see this character, this character, this character, it is this. For example, I'm trying to use these examples that you can understand. If you want to determine if a dog, for example, is a Boabu, is a Pit Bull, or is German Shepherd, the first thing you have to look at, you look at the attribute of each of these dogs. For example, if you are looking at German Shepherd, for example, you can tell the machine if the length of the ear is long. Don't forget, German Shepherd ear is long if you are used to dogs. If the ear is long, okay, maybe the ear is 5 centimeter. If the ear on the body is also long, then if the back foot is bent, if the head is maybe the head is 10 centimeter, for example, you can say this is German Shepherd. Now you can tell your machines, when time the machine sees a dog with long ear, head with 5 centimeter, and the back foot lower than the front foot, it will tell you this is German Shepherd. Then if it is Boabu, the moment the computer sees that the ear on the body of the dog is not long, the ear, even this ear is not long, the body ears too are not long, but the head is bigger than 10 centimeter, the machine will quickly recognize you and say, yes, this is not a German Shepherd, this is a Boabu. So that is how you train. So all these attributes are the things you will put together to train the machine. The machine will learn. That's what is called machine learning. So it is a technique of teaching your machine that, okay, when you see this, you should know it is this. When you see that, you should know it is that. You understand? For example, when it is May, you are done with exam, then you should know that you are already going to what? To summer, isn't it? So that is the way you train your body. That is the way. So the same thing, you can train your machine, you can train your laptop, you can train your smartphones that, okay, when you see all these attributes, this is what is going to happen. You understand? So in the case of man and human, we learn from experience. So we know that when you see the cloud dark and you are seeing thundering, your memory knows it is about to rain, isn't it? Are you guys with me? Hello?
Yes, Dr. Dawo.
I believe you understand. I know I'm using different illustration. So when you see the cloud dark and you see the thunder, you already know, your brain signals to you that, hi guy, is about to rain. So the same way you can give all this information to the computer, and the computer will tell you, okay, with this information you have given to me and what you've trained me in the past, this is likely to happen. That is likely to happen. The same thing is applicable to facial recognition. When you show your face to your laptop, maybe to your phone, to your Siri or anyone, Alexa or anyone, when you show your face to it, automatically it takes measurement of your nose, your eyes, the length of your nose to your eyes, the length of your 2 eyes, the length of your ear to your nose. It takes those measurements automatically. So anybody that is coming up now that is not having the same length of measurement like you, the machine will automatically recognize that you are not the one. It won't unlock. But the moment you show yourself, it takes that measurement and see that, okay, this is the actual measurement I've taken originally that I've been told about. Okay, this is Nensoma, this is Mensoma, this is Taming. So that's what is also machine learning is an advanced technique that teaches computer to do what naturally comes to human and animal. And we learn from experience. Both human and animals will learn from experience. So machine learning algorithms use computational methods. They call them computational methods to learn information directly from data without relying on predetermined equation as a model. No, it learns directly from data. For example, now, if you want to know, maybe you want to recognize a pregnant woman from a non-pregnant woman. You understand? there are some parameters you are going to take. Maybe the length of the tummy, maybe the insulin level, hormonal level. Once you put you already have the hormonal level for a pregnant woman, size of the tummy, all those parameters, and you tell it to your machine, all these parameters shows a pregnant woman. Now, when you now have another data of non-pregnant woman, definitely there's going to be difference in these parameters, right? In these parameters, definitely the machine will learn, okay, anybody with this kind of parameter is non-pregnant, anybody with this kind of parameter is pregnant. So the machine learning, the machine will learn using algorithm from data. And once it learns from data, it will store it in its brain and say, okay, anybody that has this is this, anybody that has that is that. So the algorithm, so you can go to this link to read more about this. I will send you this at the end of the class today. So the algorithm adaptively improve their performance as the number of samples available for learning increases. So as you have more data, those things will begin to improve in their performance. Just like as you gain more experience, as you have more experience, you have more wisdom. So the more they are also having more number of samples, more number of data, the more they are also improving their performance. So another aspect of it is what is called deep learning. Deep learning is a specialized form of machine learning. It's the same approach, but it's more specialized than machine learning. And like I've said, how much learning, how machine learning works is simple. Machine learning uses two types of techniques. The first technique is called supervised learning. There are two types of machine learning techniques. We have supervised learning and unsupervised learning. Supervised learning, which trains a model on unknown input and output data, so it can predict the future output. Can you see that? So supervised learning, if you take in this supervised learning, you already have an input, and you also say to the machine, if you have this input, this is the output. If you see a man that is, if you see a man that is a woman that has a protrude tummy, that has a record level of HCG, human gonadotropin level, that has excess estrogen, then you tell that is all those parameters are the input. Protrude tummy, HCG level increase, estrogen level increase. Those are the input. The output is a pregnant woman. So you supervised learning, you give the machine the machine the information, the input, and you also give the output. So next time, what the machine will be looking for is a protrude tummy, HCG in urine, high level of estrogen. It will tell you a pregnant woman. So when you now have a non-protrude tummy, no HCG in the urine, and low level of estrogen, those are the input. The output is a non-pregnant woman. So can you see what is meant by unsupervised? We supervise by telling the machine the attribute it should be looking for and the outcome, which is the output it should be looking for. That is a supervised learning. So when you give it an input, it will get an output. So in the future, when the machine come across a similar kind of information, it will be able to tell you, okay, with what I've seen, this is likely to be this. That is a supervised learning. Now, unsupervised learning, which find hidden pattern or intrinsic pattern in input. Now, unsupervised learning, you don't really have an input. You don't really have an input or an output. What you just have is you have data, and machine by itself will follow the pattern. What is the pattern? For example, if you want to look at does ethnicity affect the prevalence of COVID-19? Are you getting me? All you need to do is, as a scientist, go to maybe to Houston area, look at the number of, ask for the number of SARS-CoV-2, maybe SARS-CoV-2 in Houston area A, What is the number of people that have SARS-CoV-2 in that area? How many of them are black? How many of them are white? Another area, go to another area, maybe Houston B. How many people are black? How many people are white? How many people have SARS-CoV-2? So, we don't know whether the number of SARS-CoV-2 that we have daily is dependent on the number of black people that lives in that environment or number of white people that live in that environment. Once you get all the information together, put it together, and you give it to your to the machine. The machine will look at it, study the data, and it will give you an output that after I've studied this data, this is the pattern. Okay, when there is less black people, there is more COVID-19. Or when there is more people, more black people, there is more COVID-19. So it is the machine that will study the data and give you that this is the pattern I've seen. You understand what I'm saying? So can you see the difference between the two of them? The first one, supervised learning, you give an input and you tell the machine what the output is. We are going to do that example today. You give the machine an input and we are going to tell the machine what the output is expected of. The other one on supervised learning is you give the data to the machine and the machine will be the one to find a hidden pattern or intrinsic structure in the input data. That is, so those are the two techniques of machine learning, supervised and unsupervised. And to make things easier for anybody that is doing artificial intelligence, like I was telling you, the basic thing is for you to understand the script, which we have been talking about, we have been learning, Python programming. There are already built model. There are model already built that you just need to utilize. Once you utilize, you don't even need to know how they come about those models. Just have understanding of how the models work, utilize those models, and you can determine whatever you want to do. So I try to put more explanation on this, which I think I've mentioned many of them. So supervised machine learning built a model that made predictions based on evidence in the presence of uncertainty. So it's going to make use of a model. It will work on input, and there will be an output. So supervised learning algorithm takes a known data and known response. You can see it will take a known input data and a known response. Like the example I use, a proteotomy, positive HCG in the urine, high level of estrogen, that is the data. The output means that person is pregnant. So it will take an input data and give you, and you also give the machine the output. This is a pregnant woman. So next time when you give a data to the machine, maybe you have a proteotomy, low HCG, and there is low estrogen, the machine will tell you this person is not pregnant. Definitely maybe the person had obesity or maybe the person has overfed himself. That's why it's having a proteotomy. Because if it is pregnant, a proteotomy, positive HCG and high estrogen will be the data. You understand how that works? So that's how it works. Now, supervised learning uses classification and regression methods. You can read more this. So, like I've explained how each of them work, right? Now, I want to show okay, let's go to this URL. Yeah, this is it now. Let me so this is machine learning, supervised and supervised learning. So under the supervised learning, we have what is called regression and we have classification. If you want to classify, maybe you have a parameter you want to classify, either if you have a data, you can say, okay, this person is HIV positive, this person is not HIV positive. That's classification. Classification, you want to see whether someone is this or that. Maybe is it a boy or a girl? Is it a German Shepherd or a Babu? Is it Ford? Is the car Ford or is it Mercedes? So that's what is called classification. Then we also have regression. The regression tool is also a supervised learning of class, or is like classification also, that will tell you, okay, this one belongs to this, that one belongs to that. And we also have the unsupervised, and what using the clustering method. So I want to show you some of, I think I have the diagram. Yes. Now let me show you this. Now in this manner. Now let me, so for the supervised, for the supervised learning, classification technique district response. Example, whether an email is genuine or spam. That is the example you see. Don't you ask yourself, why is it that when people send email to your Gmail, some will go to spam, some will go to your inbox? Because with time, your email address or your email server already know the kind of email that you receive. It has studied the kind of email that you receive on your email or in your inbox. So anytime it sees an email that is not similar to what you usually see in your inbox, it will send it to spam. Can you see? So as you are doing your email, receiving email, sending out email, your laptop, the algorithm responsible for your Yahoo Mail or Gmail is already trained to recognize the type of email that you receive or you send. So when you have an email message that is unusual, it will send it to spam. Or it can also predict whether a tumor is cancerous or a benign tumor. A benign tumor is just a swelling. It is not a cancer. Why another tumor can be cancerous. So based on some biochemical parameters and anatomical parameters, the machine can learn whether this tumor that you are seeing is cancerous or benign. That's classification. Or you want to know whether someone is a boy or a girl. That's classification. So use classification if your data can be tagged, categorized, or separated into specific group. That's what classification techniques of supervised learning is all about. Regression predict continuous response. For example, regression techniques predict continuous responses. For example, how to measure physical quantity, such as battery state of charge, electricity load, or price of financial market. People that predict market, this is the regression techniques they use to predict, okay, how has the market been moving in the past? Okay, let's use techniques to see how is it going to move tomorrow. So that's the techniques. So another thing is, for the unsupervised learning, is what is called clustering. The literal meaning of clustering. Clustering is when some things cluster together in one area. For example, when you have maybe you have the height of 50 students, and you want to say, okay, these 50 students, how are they close to each other in their height or age? For example, once you put the data in the machine can help you to separate them. Okay, these people have similar age. Maybe these people are from maybe between 20 to 25. Then these ones have a similar age, maybe from 26 to 30. While these people have similar age, maybe from 15 to 20. So it will cluster. So it will put the data together based on their similarity. So that's what that is. And this is what is this. These are the algorithm, machine learning algorithm I was talking about. There are different algorithms to predict machine. There are different algorithms. We are going to learn many of them. And today we are going to do one of them. Supervised learning, anytime you are doing classification, you use support motor vector or discriminant analysis or naive Bayes or nearest neighbor. All these are algorithms that are available on Python. If you are looking at regression, you can look at linear regression, GLM, SVR, GPR, assembly method, decision tree, or neural network. And if you are looking at unsupervised learning, clustering, we have K-means, we have K-methods, we have Fuzzy C-means, we have hierarchical, Gaussian mixture, neural network, and hidden Markov model. So if you are doing machine learning, it is good to have this thing even as a picture on your phone, so that when you look at your data, then you can say, okay, this data, is it a supervised learning or unsupervised learning, so that you will know which method you are going to use. If it is supervised learning, is it a classified type of learning or regression? If it is classified, then you can look at which model let's use, which computational algorithm let's use for this, for your data. So that's how what machine learning is all about. So how do you decide now? This is like how do you decide which machine learning algorithm to use? If you want to have a good output, it depends on which algorithm you are going to use. And to do that simply is to understand your data. Choosing the right algorithm can still overwhelming. There are dozens of supervised and unsupervised machine learning algorithms. Each takes a different approach to learn. There is no best method or one size fits all. Finding the right algorithm is partially just trial and error. Even highly experienced scientists can't tell whether an algorithm will work without trying it out. But algorithm selection also depends on the size and type of data. Even though the basic thing is the size of your data and the type of data. And you can only know that by studying your data. And what people do, it is difficult to say this particular model is going to work for my work or that will work for my work. No. What people do most is you can try all the, for example, if you are working on, if your data is supervised learning data and its classification, you can decide to use all these 4 models on your data. Once you use it, it's going to score it. So which one give you a good score? The score is going to be over 1. It's called R square. If the R square is the higher the value of the R square, the better the algorithm. If the R score is 0.1, it is not as good as when the R score is 0.8. You understand? So it is for you to know which one you are going to use. It has to do with one, your data size, and the type of data you are working with. Yes, once you know that, and you know it is supervised classification or supervised regression, then you can try all this model on your data and see which one is going to give you the best performance. Do we get that? Any questions so far on explaining machine learning before we go into a practical sense of it? Any question?
No questions from me, sir.
Me?
No questions, Dr. Joe.
Okay. But I think you understand what I'm trying to explain there about machine learning.
Yeah, it was explaining, like it wasn't too complicated so far.
Yeah. It's just a natural way. All of us will learn from experience, right? We learn from experience. So in the same way, you can make your machine to learn by supplying the input and the output. So next time, the machine will be able to predict for you this and that. So let's go to one example, one simple example I already made. Sorry, I can see. Yes, this is what I call the introduction to machine learning 2. And today we are going to work on, when you see naive Bayes, that means our data is, we are working on we are going on supervised machine learning. Let me show you. You see, naive Bayes is under supervised machine learning classification, right? So we are looking at naive Bayes, and what we want to predict now, we want to predict outdoor playing condition. Now, when you have kids, for example, my boy can come to me and say, Daddy, I want to go and play outside. Before I will say yes, I have to go and look at the weather. What is the weather? Is it too hot? Is it sunny? Okay, if the weather is conducive, I will say yes, go and play. If the weather is not conducive, I will say no, right? So we have what we are going to do now is we are going to predict some weather conditions. You understand? And we are going to we are going to give weather condition, we are going to give the temperature, and we are going to give whether to play or not to play. So in this case, this example is based on the effect of environmental condition on the outdoor playing possibility. So weather condition will determine whether I will allow my boy or even myself to go and play outside. Now, so our data set contains two features. Now, when we are talking about features in machine learning, feature is talking about the input data, the character. That's the anytime you see me talking about features, I'm talking about the input data. You understand? The character of what you are doing. And the first one is going to be weather and temperature. Under the weather, we have sunny weather, we have overcast, we have rainy. The other feature is temperature. If the temperature is hot, mid, or cold or cool. The temperature is hot, mid, or cool. Now, label the data sets. The label for data set are either yes or no. So the label now is the output. So, you know, when I look at the weather sunny and the temperature is hot, then what will be my decision? What will be my outcome? I will say, no, don't play. If the weather is overcast and the temperature is mid, I will say, yes, go and play. So the features is the weather and temperature, while the label is the output, yes or no, whether I should go and play or no. So in this place, the first thing, I create a data set here, assigning features and label variables. So this is the weather, right? Weather is equal to sunny, you can just type it. Or do we put one sunny? So when it is, now look at it, I have weather, I have temperature, and I have play. When maybe the first day, the weather is sunny, right? The temperature is hot. I said, no, don't play. So when the weather is sunny and the temperature is hot, my response to that request is no, don't play. When the weather is sunny, the another day, the weather is sunny, the temperature is hot, my response is what? No, don't play. Now, again, maybe the third day, it comes to me and said, Daddy, the weather is overcast and the temperature is hot. My response is yes. Since it is not sunny, it is overcast, and even though the temperature is hot, yes, you can go and play. Can you see that? So these two are the features, and this one is the label, my output, my response. So when it is, now let's look at the next one. When it is raining, the fourth, 1, 2, 3, 4. When it is raining, 1, 2, 3, 4, and the temperature is mid, my response is yes, go and play. So all of this, when the temperature, when all of this that you are seeing shows that when the weather is rainy, everything is fine. These are my decisions. So sunny, hot, no. Sunny, hot, no. Overcast, hot, yes. Rainy, mid, yes. Rainy, cool, yes. Rainy, cool, no. Do you understand the data set? Hello? Hello?
Yes, Dr. Lewu. Well,
Do you understand? Do you understand the data set, right? No.
yes, so far, Dr. Lewu.
Yes. So that is it. So in this case now, I want to train my machine that, okay, when you see this, when you see the weather and temperature, this will be the response. When the weather is sunny and hot, tell them not to go and play. When the weather is rainy, is overcast and hot, you can tell them to play. When the weather is overcast and mid or cool, you can tell them to play. But when the weather is sunny and the temperature is hot, no time to play. Can you see? So that's what. So next time when you give the information to computer, the computer will be able to say, okay, it is time to play. No, it is time not to. It is time not to play. So, and for you, don't forget, we learn how to assign variables, whether equals to in bracket, because sunny here is a strange data. Don't forget. That's why I have it in bracket. So sunny in bracket, comma. So all the weather conditions, I list them. this point, right? Then the temperature, hot, hot. They are all string. I believe we should know that if we take time, they are all string. That's why we put them in comma. Hot, hot, cool. Now my response, play. Is it to play or not to play? No, no, yes, based on these two conditions, isn't it? So when, don't mind me. So we assign that. So let's see what we did. Can you see now? What print weather? Weather is sunny, sunny, overcast. This. When we print temperature, hot, hot. This. Play. Also, if you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All these two must be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because as I'm taking this information, as I'm taking the weather report, I'm also taking the temperature and I'm giving my response. So can you see that now? So you can see this is a supervised learning, right? Because we are giving the computer our input. In this case, our input is weather and temperature. And at the same time, our output is play or no play, yes or no. If another method now, if, for example, if you want to see the effect of a drug, if you want to know whether a drug is working fine or not, maybe you want to see if temperature, if Tylenol is working on your patient or not, you can say, okay, what is the temperature of the person? You understand? The temperature hot. Okay, the person's, another thing that we can is, what about headache? Is having headache? If the headache is mid or high, then does the drug work? Yes. So if when the temperature of the person is low and the headache is low, definitely you can say the drug works. Yes, isn't it? So you can also use this thing like that. So anybody that comes to say, okay, well, these are my headache level, this is my temperature, automatically the machine will tell you you are fine, you are not fine. And that is exactly what happens during this COVID. You see, there are a lot of a lot of applications that will tell you, they will ask you to tell us about your COVID symptoms. Have you had any cough in the past 1 week? Yes. And have you ever traveled into a COVID hotspot before? Yes. Have you had high temperature in the past few days? And you say yes. Have you had a cough in the past few days? Yes. At the end of it, it will give you are likely to have COVID symptoms. That's the way it is. Exactly the way it is. So the same thing here, that is a kind of supervised learning classification. So we want to classify the input to either yes or no, either COVID positive or COVID negative. That is what we are trying to do. Now, so let's go to the next place. Now, in this case now, the algorithm we want to use here to do this calculation is called naive Bayes classifier. And this naive Bayes is in, we talk about Python packages, right? And if you remember, I mentioned sklearn. Sklearn is a Python packages. And in the Python packages, it is used for machine learning. And it is what is called processing. Processing. This thing we have here, so it is really difficult for us to be able to do our prediction directly on this data. We have to do what is called processing. And this pre-processing module is in this sklearn. So what we do is we have to import from sklearn, import processing. Now, once you do that, the next thing is creating label encoder. You have to create label encoder. Now, what I mean by this is this. We need to convert this, this sunny stuff here, we won't be able to work with it. We have to assign code to sunny, overcast, and rainy, right? We have to assign code hot, mid, and cool. And we have to assign code to no and yes. You understand? Now, us to be able to do that, we need this pre-processing from sklearn mode package, and we have imported it now. Now, what you do here, you can give this any name. I just put it LE. You understand? LE equals to processing. This pre-processing dot in pre-processing we have label encoder. We want to give code. LE equals to label encoder. We can use this label pre-processing dot label encoder here, but because it's two names, we assign it a name. Pre-processing dot label encoder is equals to LE. Anytime I want to process a data, anytime we want to encode a data, instead of typing all this, you just have to use LE. Now, what you are trying to do is converting string label into numbers. All these string label that you are seeing here, you want to convert them to numbers. And to do that, so we want to encode the for weather, right? So we give it a new variable name, weather underscore encoded equals to LE, that's processing encoder dot fit underscore transform weather. So we want to transform this weather, sunny, all of them to code. And the code is either 1, 2, 3, 4, 5. So once we do that, it will automatically transform this thing. It will assign a code to all of them. And it will give us, let's print it out now. I already do that. Oh, this one of the thing I don't know. Okay, yeah. You see that now. So what it says here now, I want you to have a look at this. So it converts sunny to overcast is 0, rainy is 1. Can you see? So by converting them, the computer already know that anytime you see 2, it is sunny. Anytime you see 0, it is overcast. Anytime you see rainy, it is 1. Can you see that? So based on what we have here, if sunny is 2, sunny, can you see 2? Sunny 2, overcast 0, rainy 1, rainy 1, rainy 1. So sunny is 2, overcast is 0, rainy is 1. So because we have to put it in a way that the machine will understand. So we already assigned, let me put something here now. So let me see. So the machine assigned code the weather. So we have sun equals 2, overcast equals 0, and rain equals 1. Can you see that? That is what the machine just did. Now, the same way, since we have done for the weather, we have to do the same thing for temperature and play. So if you look at it, can you see we just put temperature encoded using the same preprocessing dot label encode dot fit transform temp. So transform temperature, transform label PA2. So can you see? So in this case, for temperature now, for temperature, hot equals 1. I'm just putting this so that for you to understand. Mid equals 2, and play and cool equals 0. Now, for play, no equals 0, and yes equals 1. Can you see that? So the purpose of this thing is to convert this string into a code, a number code for us. It does not affect our data. We are just trying to put it in a simple code that computer can understand. So another thing I did here, which is not really necessary, is making a NumPy. You know, NumPy is a NumPy and is for data analysis. NumPy array. So now, so if you look, don't forget that I said weather and temperature they are the features, right? They are the features. Why play yes or no is the label. Again, the features are the characteristics, the input. Why the label is the output. Weather, temperature, they are the input that you give to the machine. The output is either to play or not to play. So in this, so the NumPy, so we have to make a NumPy array of the features. So numpy.column_stack. What this means is we want to match our features together. That's temperature and weather. So and don't forget, we already convert them to code. And for weather, we name it weather_coded, and temperature is temperature_coded, right? And once you do, sorry, I didn't import that on this. Okay. Now, what we do here is we put all our features together, the features together. That's the weather coded and the temperature encoded. Weather encoded, temperature encoded. So we put them together. And if you look at our raw data, the first one is 2, 1, right? 2, 1, and 2 for weather is what? 2 for weather is sunny, and 1 is hot. So that is the data we have here. These two data that we have here, we represent it in a NumPy in an array format, in array data. Can you see? 2, 1. So this is when it is sunny, the weather is hot. Don't forget, 1 is hot, 2 is sunny. When 0 is I think 0 is overcast, right? If from the data 0, okay, I think I already put it for weather. So for weather, yeah, 0 is overcast. So what we have here is a code. What we have here is a code representation of what we have here, of these two. So it's not something new. What we have here is a code representation of what we have here. So sunny, if you look at the first one, when the sunny is 2, hot is 1. Look here, sunny is 2, hot is 1. If you look at the third one, 0 is overcast, hot is 1. Let's go. 0 is third one, 0, and the third is hot. So it's just a code representation of what we have there. So once we have done that, we just want to look at our data shape. Just data shape. So we have 14 columns, and we have 14 rows, 2 columns. That's the shape now. So now that we have done this, what do we do now? Now we have to build a model. Now we have already have a code. The next thing is to build the naive Bayes model, or you can call it Gaussian naive Bayes model. It is this model that we are going to use to train our machine, so that our machine can be able to predict for us what is going to be. We'll be able to predict for us whether the child should go and play or the child should stay at home. So now, for us to be able, now this is the Gaussian naive Bayes model. That is the algorithm model we are using for this classification. And we also go, like I said, the sklearn is the package for machine learning. So from sklearn.naive Bayes, import Gaussian naive Bayes, just a Gaussian NB. But this is don't forget this. If you remember what we said, we do all this machine learning by using computational model. So The computational model or computational algorithm we want to use here is the Gaussian naive Bayes. And we have to go and import it from the sklearn. Right. Once you do that, we already import a NumPy initially. So our model just create a Gaussian classifier now. Model is equals to Gaussian. We can use this Gaussian classifier directly, but to make it simple, we just give it model. Model equals to Gaussian NB, right? So when you want to do a work in machine learning, you have to use your data to train your machine. Most of the time, training data, if you use 80% of your data to train the machine and 20% of it to test. What I'm saying is, you give, if you have, in this case now, we have how many? We have 14 rows, right? 14 rows, isn't it? And we want to train this. And don't forget, when we have 14 rows, then we also have, if you use like from 1 to 10 to train the data and to let them know, okay, when you see this, play no. While the remaining 4 will be to want to test if the prediction is correct. It is when you test your data that you are going to get the quality of your model in R square. So if your data, if your prediction of, if you use 10 to train it and you use 4 to test your data, if the accuracy of data is 100%, your R square is going to be 1. If the accuracy of data is 80%, your R square is going to be 0.8. So that's why I said, when you want to try, it is difficult to know which model to use for a data. But once you know your data type, you can go and try all the model that falls under your data type. If your data is supervised learning and is classified, you can use all the listed model under the SMV, Gaussian naive Bayes, and the rest. You can use them, test them on your data and see which one is going to give you a high R square value. That's it. So in this case now, we want to train. Now, don't forget, we have label, this, and we have features. We have features and the label. Features is weather and temperature. If you don't forget, can you see the weather and temperature? And the label is the outcome, the output, right? Can you see? So what we are trying to do here is use the features and the label to train this model. So it means that we want computer to know that when you see 2, 1, the outcome, which is labeled, is no, 0. When the weather is sunny and the temperature is hot, no, it should not, the test should not play, no. So by using that, the algorithm here automatically learn all the skill from here. Can you see that? I want to. Yeah. So now, what we did here now, we imported the algorithm we want to use from sklearn, right? Then we assign the model. Model is equals to this. Then we want to train the machine with our data set. So model.fit, it means train, feature, and label. So when you see this feature, you know this is the corresponding label. So now let's predict now. So predicted now, we want to predicted now equals to model.predict. Now I now put this. So let's say after some days, my boy now come to me and say, Daddy, I want to go and play outside. And I will tell him, okay, go outside and go and look at the weather. Let's say he says the weather is 0, right? And the temperature, don't forget the arrangement. the temperature is mid. Now, let's predict. What does it say? 1. What does 1 mean? What does 1 mean for the label? It means go and play. So when the temperature is when the weather is overcast and the temperature is mid, the guy should go and play. Let's go to our weather. Remember this: when you have temperature of weather of overcast and temperature mid, what is the outcome? Overcast and temperature mid. Can you see? When the temperature is 1 to 3, when the temperature is overcast, when the weather is overcast and temperature is mid, let's see that. That means it means play. Can you see that? So someone give us one condition. Someone give us one condition for the weather and the temperature. Tell me, and then
rainy for the weather.
Rainy for the weather, and the code for rainy is what? Is 1, right?
Yes.
I think it's 1. Okay. And temperature? You want it to be cold, hot, or cool?
Let's say cold, sir. Cold.
Cold. And what is the code for cold? Let me. For cool, Abi?
Cool. 0.
Cool.
Then it's 0.
0. Okay. It's 0. So let me change this. 0 cool, right? And I think we said 1, that's raining, right? 1. This one is, I'm just quoting this. This one has something to do with the code anyway. Is raining. So I can do this. As not, you can see anytime you see hash, it means it's just a comment. It's not a code. So this is the code. So let's type this and see what the output will be. It says 1, and 1 is what? Yes or no?
1 is yes.
Yes, that means anytime the temperature is rainy and cool, based on our data, you can ask the child to go and play outside. Do you know there are times my boy will just come to me and it will be raining, and he said that I want to go and play, and I permit him because I understand. All those play are not always common here, but where we come from, majority of us play in the rain, all those stuff. So that's why it is. You see, this one is saying play. Let's try another condition. So let's say the weather is sunny, right? And the weather is sunny and the temperature is mid. Let's see what it's going to give us. The weather is sunny. Let's predict. It says no, don't play. Can you see that? So when the weather is sunny and the temperature is mid, it says no, don't play. So can you see how this? So next time we don't need to this thing we did now. The machine already has the information. We don't need to train the weather again. What you need to do next time is just provide the information to the machine, and the machine will give you the possible outcome. Do you understand? And that is the concept in hospitals. By mere showing picture of X-ray picture to some machine, it will tell you whether the person has asthma or not. If you show the picture, the radiography picture of lungs, of a human lung to some computer, it will automatically tell you this picture you are showing me, this lung is asthmatic or not asthmatic, because they have already programmed the machine with the characteristics, with the features of an asthmatic lung. Can you imagine? So that is the concept. So they don't need to say that to the machine again. Once they already have the information, like I learned there is a research going on in one university, I think Baylor. I can't remember. I was in a program sometimes, 2 weeks ago, and they said they are doing a kind of study now that every patient that comes for cancer treatment, they get the picture and they already have what they are putting down the attribute of those pictures. So what they are doing is they are training their machine to recognize, I think maybe it's prostate cancer or so, to recognize, okay, this is prostate cancer, this is how prostate cancer look like. So they get all those characteristics. Maybe the prostate is big or it is small, the color is this and that. So anybody that is coming after many years, all you just need to do is get the picture of the prostate gland, show it to the machine, and the machine will tell you this person is positive or negative of prostate cancer. Or it will even say, it can tell them, okay, this is going to be stage 1 or stage 2 or stage 3 or stage 4, whatever cancer. That is what they do. So when you get that same information too, you can do something similar. So are you getting it? So that's that. So what we have here now is you can just use it to predict. Now, in this first condition, if the weather is overcast and mid, the computer says, yes, let the child go and play. In this case, if it is raining, and if the weather is raining and the temperature is cool, yes, you can let the child go and play. But in this condition, if the weather is sunny and the temperature is mid, it says no, 0. The child shouldn't go out to play. So before we go, let's add one more features to this. Let's add humidity. Yes, I want us to add humidity to it. So this is the humidity for each of these days. The first one, high, medium, low, low, medium. So in that case, so we include humidity in it, in the data, then we convert it to a number code. Don't forget. So we name it as humidity underscore encoded. So preprocessing transform humidity now. So preprocessing will transform humidity to a code, and we print out. So it says when it is high, the code for high is 0, medium is 2, and low is 1. Can you see that? So now we want to do another feature. So we don't want to affect this particular feature. So you have to define. So when you are doing this, you have to define your features. That's the input data, and you have to define the label. That's the output data. So what you are doing now is we are defining the input data. So the features. So we have numpy. We want to have it in array :stack. We have weather encoded, temperature encoded, and humidity encoded. So that is why we are having. So when the weather is sunny and the temperature is, I think this is hot also, yes, and the humidity is high, so is high. What should we ask the child to do? Should the child go and play or stay inside? So once we do that, and we don't forget, we already have our label. The label is already there. So the next thing is to import our Gaussian method. So we already import it. So give it label. We don't want to overwrite this one, because if you use the same word, it automatically overwrite all this one. That's why we are putting _3. So labels features _3. The same thing as model. The other one we use model. So this one we put model _3 is Gaussian NB is model _3. So what you do now is train. Don't forget, you have to train your label, your features against your label. So when you have all this label, what is the outcome? For example, if you look at this, the first play is 0, right? So when you have a sunny weather, a hot weather, and you have 0, that's high humidity. Since the first label is 0, that means the child should not go and play. So we use that to train the machine, right? So we train the machine with that. So what we are trying to do is we are matching all these features with the corresponding label, so that the machine will know the response. So now let's now do a prediction now. Let me just cut this one. I don't want to Ctrl X. So what we did here, we trained. Now, so what we did there, we already trained. So we let the machine already know that when you see this code, the play output is, for example, this one is zero, no, right? So let's go and pick it now. So when gifted underscore tree now, when the weather is overcast and the temperature is mid and the humidity is medium, what should the child go and play or stay indoor? Let's run it. It says what? Yes, let him go and play, isn't it? Can someone give us some conditions? Give us what weather condition? Give us one weather condition.
Let's say sunny.
Sunny is 2. Okay. The temperature?
And temperature should be cool. Can it be cool? Sunny?
Okay. Cool. I think cool is 1, right?
Yes.
And what is the humidity? High, low, or mid?
We'll say or mild. Or
Mild. Okay.
yes.
Or you want it to be cool, to be low?
Okay, let's
right?
do low. Let's do low.
Okay. What is the code for low? Sorry, low is 1.
Low is 1.
Okay. So computer, should the child go out of the play or not? It says no. Can you see that? It says no. Do not go out to play. So we have trained. Let's do one more. Let's do one more condition again. Can someone give us one more condition? Mesoma? Mesoma? Is Mesoma still available? Okay, let's do another condition again. Someone should give us another condition. So let's say the temperature is, I think we have sunny, we have rainy, and we have what other one? So let's say the temperature is 1. So the weather is 1, temperature is 0, and we have the humidity 2. So the child go out to play. It says yes. So when the humidity is low, yes. And when the humidity is low and the weather is the temperature is cool. No, the temperature is high, and the weather is rainy. It says the child can go out to play. Do we understand the concept?
Yes, Dr. Oduwa.
So let me just give the summary of everything. Is machine learning is a technique of making the machine to learn what we human beings learn naturally from experience. Ordinarily, I know when it is raining, when the temperature is high, a child shouldn't go out to play. Yes, I know as human being based on experience. But how do the machine know to predict and tell someone that doesn't know that the child shouldn't go out to play? To do that, we have to train the machine by providing data to the machine, and the machine will learn from it. So that is what is called machine learning. Computer learn, you learn, everybody learn. So the machine will learn from the data you have supplied, and the machine will be able to predict in the future, okay, this is the possible outcome. And I use an example of the weather condition. The American Meteorology Department, they will come and say, tomorrow there's going to be thunderstorm. They were able to say there's going to be thunderstorm because they already have parameters on ground, a lot of atmospheric conditions, maybe humidity, temperature, and a lot of parameters that they already have. They study that from beginning, and it's okay if we can have these parameters. It's like to be rainy, to be sunny, or to have a snowstorm, for example. So those are the things so they already trained their machines already with all this data. So what they do is they take measurement of these things every day. And the moment they feed it into their data, the machine will tell them, with the data you've given to me, it's likely to rain tomorrow, or it's likely to be sunny in the next 1 hour. That's how it works. So they train their machine, and their machine will be able to predict outcome for the future for them. And I said in machine learning, when you are doing this, there are two different techniques of machine learning. We have the supervised learning, whereby you supply the input and the output to the machine. Why the other type of machine learning is unsupervised learning. This unsupervised learning is just a kind of learning that the machine will look for pattern. You don't have, even you yourself don't actually know the pattern, but the machine will be the one to look for the pattern. And I give example, you want to know, does the presence of minority, maybe black or even white, does it has effect on number of COVID output that we have daily? And once you want how to do that, go out to different places, know the number of COVID that happens in those areas per day, know the number of black and white people that happens there, do it for different areas, enter the data into your machine, and machine can give you the pattern. Okay, I can see high number of COVID-19 cases when there are high number of white people, or I can see high number of COVID-19 when there are high number of black people in that area, or I can see low number of COVID-19 when there are more white people or when there are more black people. That's supervised learning. And I said when you are working on supervised learning, and I said in this today we look at naive-based classification is one method used for algorithm used for machine learning algorithm, because there are different algorithms for different type of machine learning. If you are working with classification, there is support vector machine algorithm, there is discriminant analysis, there is naive-based algorithm, there is nearest neighbor algorithm. And I said in the example we use, we look at predicting whether a child should go and play or not based on the weather and the temperature. And once to do that, you need to define your feature. The features are the inputs that you give to the machine, like the weather and the temperature. And your label is the output. Okay, go out to play, don't go out to play, yes or no. Another example that I use is you want to know if a car is Toyota, Ford, or Mercedes. What you just need to do is get the features, the characteristics of a Toyota car. Maybe you look at the logo, you look at some other things, and you get for Toyota, you get for Ford, you get for Mercedes, you get for Hyundai, as much as you want to do. Supply the input to the computer, and also give the output to the computer. So when you see a logo, this logo, it is Mercedes. When you see this logo, it is Toyota. So you use that to train the machine. So next time when you come with a new car, a new logo, at the moment you put the logo into your machine, the machine will tell you this logo you are showing to me means this car belongs to Toyota or this car belongs to Mercedes. That's so define the features, define the label. And I said once you do that, the next thing what you did is to in this case we convert, because we have our data in string. All of them are in string. And for us to be able to work with it, we have to convert it to a code. And we use what is called pre-processing from sklearn package. We use that to convert all these things to code. We have sunny is 2, overcast is 0, rainy is 1. So we did that, we convert it, and we're able to, once we converted it, we define our labels. We see our labels, the label is clear. and the features is weather and temperature that we have. And after that, we import our algorithm, the model, the Gaussian naive-based model. That if you are using support vector motors, you import support motor vectors from sklearn, depending on which one you want to use. Do you understand? You can use that. So I think we can can we try and use one? Let's try and use let's try to do this because of time. Okay, look what I will look for another data that we are going to use, either support vector motor or any other algorithm on. So that's how it is, and you can see the machine was able to, after we've supplied the features, the weather and the temperature, the machine was able to predict to us and say the child should go and play or the child should not go and play. I want to believe you understand this clearly. Do you understand this clearly? So the next class, we will take time to do one more with using another form of another algorithm. Do we have any questions?